Assalamu alaikum everyone. Today we are going to show our lab 4 assessment for the ECF. Our lecturer is Tia Saleha binti Muhammad Saleha. Here is a symbol of oscilloscope which is the related with our this lab. Myself Ratul Islam RUHIN B0820104771 from BEA 1 by 1, and my partner is Khairil Azizi bin Abu Bakar. He is also from BA 1 by 1. For this lab assessment, I took part question 1 and question 3. Here is the question 1, function of function generator. A function generator is a signal source that has the capability of producing different types of waveforms as its output signal. The most common output waveforms are sine waves, triangular waves, square waves, and sawtooth waves. The frequencies of such waveforms may be adjusted from a function of a hertz to several hundred kilohertz. The most function generators allow to generate sine, square wave, triangular AC function signals.
Assalamualaikum. My name is Khairil Azizi and I will presenting the function of oscilloscope. Oscilloscopes or scopes test and display voltage signals as waveforms, visual representation of the variation of voltage over time. The signals are plotted on a graph which shows how the signal changes. The vertical y-axis represents the voltage measurement and the horizontal x-axis represents time.
Now I am going to describe about the question 3. Here is the question 3. Explanation to determine the period and peak-to-peak voltage for the signals from the lab part A. For doing lab part A, we need to go multisim. Here I am in multisim. For this lab, we set a function generator. Here is a function generator and oscilloscope. Here is the oscilloscope. First, we need to connect positive to positive and the common with the oscilloscope negative part, and we need to place ground component. Here is the ground component. Since we are working on just channel A, so here is the channel A. We don't need to connect channel B. Now here is the oscilloscope display and the function generator display. In function generator, we must set as frequency as a 2 according to the lab sheet and amplitude as 3. And here channel A, we need to settle it AC because we are working on AC. In channel A, channel B, we don't need anything to do because channel B is not connected. Here is, we want a single trigger, and channel A we need to set 1 volt per division. Now run. We can see the proper wave, full wave, so we need to change the scale in the time base. is the 15 millisecond per division and on volt per division. Here is peak to peak, so we can see that we are moving 3 box upper in the x coordinate and 3 box lower in the x coordinate. So we got peak here. From here we got 6 volt, 1 2 3 4 5 6, and if we want a full wave we move to 1 2 3 4 5 6 7 8 9 and 10, and the duration is 500 millisecond. So this is our part A. We got the full wave by oscilloscope. Thank you so much, and the further discussion will do my partner Khairil Azizi. Thank you everyone.
Question 4. Part B. Explanation to determine the phase angle for RC circuit and RL circuit. State the relationship between input and output signal for both circuit, lead and lag. So this is our RC circuit. This is function generator. This is oscilloscope. This is the capacitor, and the value for capacitance is 10 micro. This is resistor 33 ohm. For the frequency we use 2 kilohertz. And to find the phase angle for calculation, first we have to find XC. Formula for XC is 1 over 2 pi FC. We put in the value 1 over 2 pi times 2k times 10 micro. Then we will get the value 7.96 ohm. For angle, we use inverse tangent times XC over R. We put in the value 7.96 for XC, 33 for R, and we will get 13.56 degree. For measurement, we use 360 over D times Y. For D and Y, we have to find it in the circuit. So we run it. For RC, we get this wave. So for D, we have to get the 1 cycle, 1 full cycle. Try to get the best value. And we get 500. So we put 500 here, and Y, for Y, we find the difference. So we get here T2 minus T1. This is the value, 18.83 microsecond. So we put in the value and we will get 13.56, same as the calculation. So we know that this lead. So for the RL circuit, the circuit is the same as the RC, but we replace the capacitor with inductor. The value for inductor is 6 milli. So the frequency is still the same, right? We will get this wave. So stop. And for calculation, first we have to find XL. Formula for XL is 2 pi FL. We put in the value 2 pi times 2k times negative 6 milli. We get negative 75.4 ohms. For the phase, for the angle, we use inverse tangent XL over R. So we put in the value and we will get negative 66.36. For measurement, we use 360 over D times Y. For D and Y, we use the same method as the previous, and we put in the value. So this is the D. To find the D, we get 500, and this is for Y. We get negative 19.4. So we put in, and we will get negative 65.088. So we know that this circuit is black. So thank you for me.